Solar regular. Our project members are Abhishek Vakaria, Devansh Modi and Jinay Mehta. Our project is guided by Professor Radhika Patwardhan and technician Kimaya Maikar. So our project is solar regular, which means a microcontroller based solar charger, or which is used to charge in a 12-volt battery. As in our project, it is application that we are charging a 12-volt battery with the help of solar panel and the circuitry. The main reason behind using or developing this project, or the main idea behind this project, is as the conventional sources of energy are depleting day by day. So renewable sources of energy is the need of the hour. This project is very efficient in many of the ways, and it also helps in reducing the power consumption. It also helps to increase the power generation of power generation. When implemented on a large scale, it can help to increase the power capability of for charging any type of systems. So the features of a project are: it has automatic dusk to dawn sensor, built-in digital voltmeter, that is 0 to 20 volt range, parallel or shunt type regulation, overcharge protection, system status display on LCD, deep discharge connection, deep battery lock, charging current changes to pulsed at full charge, low current consumption, highly efficient, etc. So these are the features of solar regular. Okay, so the next is nothing but the various components that we are using in our project. The components are BC547 MOSFETs, IRF 540 transistors, IN 4007 diodes, rectifier diodes 6A4, etc. resistors, capacitors. Okay, relay, that is a 12 volt relay. Software requirements are Metalink ASM51, that is the burner, and Kill C, etc. for program generating the hex file, etc. So I would like to explain the features or the blocks of the components that we are using in short. Microcontroller. The microcontroller we are using is 8089C2051, which has a 8-bit. It is a 8-bit microcontroller, high performance, 2 KB of flash memory, 128 bytes of RAM, 15 input-output line, 16-bit timers, counters, a 5-vector 2-level interrupt architecture, a full duplex serial port, a precision analog comparator on a chip oscillator, and a circuitry, clock circuitry. A 12 MHz crystal is used for providing the clock. Okay. So yeah. Serial ADC, the microcontroller monitors the battery voltage, and with the help of an analog to digital converter. The ADC is an 8-bit successive approximation analog to digital converter with a serial I/O and a very low conversion time of 32 microseconds. So it is efficient and it is an advantage. The LCD module, the system status. The LCD module which we have used here is used to display the system status and the battery voltage on the LCD based on the HD447840 controller. The backlight features of the LCD makes it readable even in low light conditions. The LCD is used here in 4-bit mode to save the microcontroller port pins. Usually the 8-bit mode of interfacing with the microcontroller requires 11 pins, and 4-bit of interfacing requires 7 pins. So we have used the 4-bit mode, which is very efficient by saving the pins of microcontroller. So you can see as the LCD we are using the 4-bit mode. So this is the 4-bit mode we are using LCD. This is the microcontroller on the circuitry. That is a microcontroller IC. This is a ADC IC over here, if you can see it, etc. Okay. Now there is a rechargeable battery. The solar energy is converted. You can see this is a rechargeable battery of 12 volt. Okay, dusk to dawn sensor. Okay, you can see here dusk to dawn sensor. It is formed normally in solar based installation. For example, solar lighting system, solar lantern, or solar street light. The load is switched to on at the dusk and switched off at the dawn. So this is the as you can see, the dusk to dawn sensor, the application. The microcontroller needs to know the presence of the solar voltage. So the dusk to dawn sensor is formed by the circuit R8, R9 and Zener diode ZT1, which can be clearly seen over here, and the transistor T1 for the presence of the panel voltages. So the basic use of the restaurant sensor is to know that whether it is a sunlight is present or not. If the sunlight is present, then it will display the message, and if it's not, then it will display the message that is the load on. Okay, etc. The charge controller relay, here we are using two relays, R1 and R2. As we can see here, it's a 12 volt OC relay. Okay. Now I'm going to give the circuit description of the solar regulator. As you can see, a solar panel is placed in the sunlight. So the battery, it displays on the LCD with the help of ADC that it is charging. Now the battery is in charging state. As soon as we take the solar panel off from the sunlight, or we cover it, it displays the load on message. The current from the battery flows to the load circuitry and the bulb is blown. Okay, so it indicates there is a dawn. Okay, and as soon as again we remove the cover from the solar panel, the display is charging on message that is nothing but the dawn. So now there are many applications of the solar regulator, that is it can be used in any battery oriented systems like inverter, solar power lightning systems, car batteries to charge rickshaw batteries, etc. And future scope, it has a lot of future modification, that is a solar tracking system, etc. And maximum power point tracking, etc. Other systems are there. And if number of panels are increased, we can the current generation and the power generation can also be increased and can be used in large systems. So now we conclude our project by thanking our Professor Radhika Miss, technician Kimaya Miss, and all the staff members for their support in our to us in our past sems. Thank you.